Yeah, I was wondering when we, after the quiz and everything, if we could just go over what we went over last week.
For sure.
Okay, thank you.
Can you see it?
No, Professor.
Okay, sorry. Let's see.
Okay, now we see your desktop.
You see it now?
Oh, we see your desktop. We don't see the test. There it is.
Okay.
Mr. Pham, mute the mics. Mute the mic. Hey, Mr. Pham, you need to mute the mic.
Recording in progress.
Professor, you got to shut it down. You're getting a lot of feedback.
Oh, a lot of feedback.
Oh yeah, it's getting high.
Oh man. Let's see. I try to move my iPad. Is it okay or no? Look like.
It's
No,
really
it's
bad.
like,
It's really
it's
bad.
really, really bad.
Okay.
Why don't, maybe, I just thought of something. Why don't you try muting your computer and using the microphone on the iPad as the way you communicate with us?
Okay, I hear you. Let's see.
Hold on. Thank you. Whew.
Can you hear me?
Yeah,
Hello?
that works.
Is it equal?
It's much better now. Yeah, it's clear.
Oh, okay. Okay.
Mr. Pham, we have to upload the file, the equiz 04 until tomorrow,
Yeah,
anytime tomorrow.
yeah, before 12.
Before what?
12 a.m.
Okay, thank you.
Is it you still see the screen?
We
You're
don't
not,
see a share. We just see
Yeah.
you.
that's what I was gonna say. Thank you.
So number 16 right now, right?
No,
No.
no 16.
Your share is turned off.
Okay, I know. You see the screen?
Not yet. No.
Okay now?
Nope.
Oh,
Let's see. No. Okay, now we see it. But it's just a blank screen. There's no 16 on there yet. I mean, it's your, there you go. Thank you.
mhm.
Mr. Fan, this screen you're showing is written equiz 03. It's just a typo. Mr. Fan? Okay.
Mr. Fan?
Yeah,
Somebody was mentioning the fact that on the quiz that we just did, it had quiz 3 on it, Xenodiode, but you had us download quiz 4 for 2024. Is that a clerical error? Are they still going to match up or
normally the quiz will be in the video. We're not uploaded.
right, but the Excel sheet quiz that you had us download is for quiz 4. But the one we just did was quiz 3, Xenodiode.
Yeah,
Okay, just checking.
okay. So now, do you hear okay?
Yeah, it's good.
Okay, perfect. Now, the problem is how come my iPad not so? Did you see my iPad?
No, it's not sharing it this time.
How come?
Did you click share?
On the iPad?
Share screen?
Let's see. Oh, okay. Sorry.
Okay.
Messing up.
That's okay. It's hard whenever you have more than one computer in front of you. Trust me, I know. I got 5 of them sitting in front of me right now.
Okay, now.
Yes, can see.
Perfect. Okay, last time we're talking about transistor. Okay. What I want you get okay here. See. Anyway, you see the transistor, okay? I want you to make sure, okay, you recognize this is the PNP. How do we recognize this error coming in? Okay, and the current will be IB leaving, IC leaving, IE coming. However, for NPN, okay, IB go into it, IC go into it, and IE leaving. That only thing you need. basically you can see NPN. You get the base, collector, emitter. So you get two diodes from the base collector, this diode, and the base to emitter, another one. Okay. If the diode turn on, they will be equal 0.7 volt. Okay. If the diode off, they will be open. Okay. When you're working on the left volt, then you can see, okay, this is the transistor NPN and PNP.
Oops, your screen went away.
Yeah. Okay.
So the top one is MPN and the lower one is PNP.
Right.
A good way to know that is the way the arrow is pointing.
Okay. So you know which pin will be the base, which pin will be collector, emitter. When you're working on left volt, you can see. Okay, in here, we come up with the, if you want to calculate the IC equal beta times IB. What is the beta? Beta, basically, this is the current gain of the transistor. And IE equal IC plus IB. Okay. And if you're looking on NPN, input voltage positive, VCC positive. However, PNP opposite. This is negative, and this will be negative. Okay. In here, they calculate, okay, IB, IC, IE. Okay. So let's see. What I want you want to calculate IB. If you get the IE equal IB times 1 plus beta, okay? Another one I see here equal beta times IB, okay? And if you want to calculate IB, this is a formula really neat for you, okay? And that's why you can see they get everything for you here. See that? Okay. And also, we don't want to go again. So this time you try to do over. If you get a question, let me know. Okay, now the transistor, they can be cut off. What they using transistor for cut off? They using the switching in application. That means they can be turned on or they can be turned off. Okay? And they get another one. Active region. They can be using for amplify. Okay? That means for amplify, transistor must be active. And the last one, saturation. Saturation also using for switching. Breakdown, they can be destroyed. Okay, we don't care. Now, cut off. Okay, what happened? Diode from base to emitter is off. You understand here? You get a diode here and diode here. Cut off, that means this diode here will be off. I given you an example. If you get a voltage here, 0 volt, then the diode from the base to the emitter will be off. That means they open here. They open, that means no current flow. Okay? Active. The diode from the base to emitter is on. That means this diode must be on. Okay? And diode from base to collector is off. Okay? So if they active, then this diode on. This diode will be off.
Hey, Mr. Pham, can you use your pointer?
I cannot. I don't know why.
Because a lot of times when you're explaining things, it's hard to tell what you're talking about because it's better when you have the pointer.
Yeah, but the thing that I said, I don't know why the pointer is not working. See? Otherwise, I have to reset my iPad.
Well, never mind, just do the best you can, but it will just let you know the pointer is not working.
Yeah. Normally, I don't understand. I reset. I think they will be working.
And then one last question, Mr. Pham. Back to that other screen. Yeah, this one right here. Let me ask you something. With respect to cutoff and breakdown, no, cutoff and saturation, switching. If a switch is on, is it in cutoff or saturation? And when it's off, is it in cutoff or saturation? Which one is it in when you're doing switching?
No, the thing is now, first thing you have to know how they be cut off. That means the voltage at the base less than 0.7 volt. They cut off, they open. That only thing up to now. And then if they saturation, they're telling you what VCE almost equal 0. That means collector connect to the emitter, connect to the ground. Only thing is, if you want to design amplifier, then the diode from base to the emitter must be on, and the diode from the base to collector must be off. That's what they said in here. Okay. Say saturation. VCE equal 0. For this circuitry here, they go to do the calculation. Okay. And we already get the solution. Okay. You can read through it. Try to see, can you understand or not? Okay, now you see here, okay, this is stand for IC, and this will be stand for VCE, and this will be for current IB. Okay, so if you pick a point right here, what IB equal? See right here.
60.
Yeah, 60. And now you can find out what I see. Then you go this way. Okay? Then you can get I see. So basically, IB, this is IB,
Right, the numbers on the right side.
right? If you change the IB, you change the IC, correct? If you pick a point right here, I see 100 microamp, and IC will be go up to 40 milliamp. And also, you can see what VCE going down here or going down here. So basically, this transistor controlled by IB. Gen IB, you gen IC, you gen the VCE. So that's why bipolar transistor divide by current controller. Okay? Why current controller? The thing is you gen IB, you gen IC, you gen VCE. Okay? Later on, you learning JFET. JFET will be a voltage controller. Okay? Okay, this line. They call it DC load line. Okay? So on this line, you can pick the point right here. They call it Q point. This Q point here, you know what the current I B. Okay. Also, you can get IC. And also, you can get VCE. And you can get a 3 region right here. Okay, you get a region this part here. They call a saturation. Right here, saturation. And also you get a part in here. They call a cutoff. Okay, so engineer when they design for the transistor to be amplified, they better select the Q point right here. At this point, they know IB, VCE, and also IC. Okay, why they want here? They don't want here. Q point here. That's what they don't want. Or they don't want here. That's not the one we want. Why? If you pick the Q point here, when the temperature changing, this can be moved to saturation. They amplify, they must be amplified. They cannot be saturated. If you get the Q here, okay, they can be go to cut off. That only apply for designer. Okay, we not design anything. Only thing is we need to understand. Okay, why you want to get the Q here or Q here? No problem. Okay, let's see what they said here. Point A at saturation, then I saturation equal VCC divide RC. Okay. Also, they given you here 10 volt divide 1K. That's what I saturation. The thing is when they saturated, the voltage here 0 volt. That means they connect to the ground. Okay, that you want to draw DC load
Did we lose you, Mr. Pham? Can't hear you if you're talking. There you go. I think. Mr. Pham? Oh, that's Ricardo.
Let's see, do you hear me?
Yeah, I can hear you now.
Is it any noise?
Nope.
Okay. Still got a problem. Okay, now you can see.
Whoops. Now we lost the PowerPoint.
Oh man, it will be a lot of problem.
Recording in progress.
Can you see now? Hello?
Yeah, it says electronic technician, the bipolar transistor. that was supposed to be saying?
Yeah, but the voice okay?
No, but you're echoing really bad. Got to get you one of those nice high quality noise canceling mics.
That okay now?
Yes.
Okay,
Perfect. That's great.
man.
And now we see your share as well.
Okay. So basically, still can. Okay. So this is the open cut off. You see that? Collector not connect to admitter. This is the saturation. They look like C connect to E. That means VC equal 0. They connect to ground. Okay, so this is the example. You need to do calculate IB, IC, IE, VCE. The formula will here. IB, VBB minus VBE divide RB. After you get IB, you can get IC. Okay? If you want VRC equal IC times RC. Okay? If you want VC, how can we get VC? This is the VCC. And you already know voltage drop here. Okay? So VC equal VCC minus VRC. And who tell me what VB equal? VB right here.
5 volts.
What VB equal? Who can tell me? You see that right here. VBE 0.7 volt. If I given you a meter, I say I want to measure VB. So high side connect to B. Low side must be connect to ground. So they're telling you VB equal 0.7 volt. What VE? This is the E here.
You don't have a drop there. There's no resistor there.
Correct? 0. If you calculate the VC, you take VCC minus VRC. Okay, VRC IC tab RC. Okay, any question about this example? Anything?
Mr. Pham, it says emitter bias, but this, the circuit itself is, fixed bias, right?
You mean
The name of the circuit.
the name of the circuit?
Yeah, like fixed bias, self-bias, all that type of stuff.
No, you don't have a cell bias or fixed bias. No, it's just normal.
Okay, I guess what I'm asking you, what is the name of this configuration?
No, the name just the basically DC bias
Okay,
for the transistor.
okay, thank you.
Now another example here. Okay, they say they want to know the Q point. The Q point, they want IB, IC, IE, VCE. Okay, first thing, they want IB. So the current flow here. The current flow here. And that will be IE. And you understand, plus here, minus here, 0.7 volt. Okay. So how come we get IB? If you want to draw the loop this way, IB, go to 10 volt minus 10 plus IB.
RB.
Plus
0.7.
0.0. So IB tab RB equal 10 minus, okay, equal 9.3. So IB 9.3 divide 47K. $9.3 divide 47. You get 0.198. Zero. Milli amp. And then you divide voltage to the kilo ohm. Okay, so that's what you can get IB. IC equal beta IB. And beta 200. And IE equal IB time 1 plus beta. VCE VC minus
VE.
VA. Now you have to calculate the VC. VC VCC minus
ICRC.
IC RC. Okay, and you know IC, you know RC and VCC. Okay, and they want to draw DC load line, and that's what we draw right here. One point here, one point here. Okay, this is the VCC. Okay, and if you want to calculate the IC, saturation equal VCC divide RC. Okay, 20 divide 330 ohm. Zero point 0.06. Amp equivalent
60
time
milliamps.
60.6 milliamp. That's what they get right here. So basically, for that one, if they want to draw DC load line, this line will be VCC. This line will be IC saturation. Okay, and this is the Q point right here. Q point, you can go to see what VCE equal. Okay, and also that will be IC. Okay, so admitter bias. What they want? They want shown for IE. Here. And they already show you VE. E C B. Okay. VE equal VBB. Okay. Minus 0.7. And IE equal VE divide RE. Okay. And VC, that means here, equal VCC minus ICRC. Okay. And VCE equal VC minus VE. The thing is, what you need, you have to try to do by yourself. Any confusing, any not clear, let me know. I can help you out. Okay, another way, emitter feedback bias, that means they connect from here back into here. Better than the bias, Q point still moving, not popular. So you don't care about that. Also, B bias, that means they connect this way. Okay. The least predictable Q point move with replacement, Q point move with temperature, not practical. Okay. They just let you know. Collector feedback another way. That means how to make the transistor working. This is better than emitter feedback. Q point still move. Limited application. You understand when they design act, the amplify, they don't want Q point move. They can move to saturation or they can move to the cutoff. They be no longer amplifier. Okay, so we just show you. We not deal with that. Two supply, emitter, bias. One power supply here, another power supply here. Very stable. However, we don't want what? Require two power supply. Okay? It costs more, so they don't want.
You want to operate in the active region only, right?
Yeah. This is the way they do calculation for true power supply. If you get time, you can try to see. Okay? However, what I'm telling you, try to understand in general. Don't go to detailed calculation. Why? You can run the simulation. You can get everything. Okay? Basically, some basic we have to know. This is the one. Voltage divider. Now they adding R1, R2. So basically, if you want VBB, this is a VCC. And if you want VBB, you're using voltage divider. VBB equal VCC times R2 divide R1 plus R2. This configuration you must know. In order to calculate the VBB, they will be equal VCC times R2 divide R1 plus R2. And after you get the VBB, they want VE. You understand a plot here, 0.7, okay? So VE, that means from here to round, we already know. And now VE right here. VE equal VBB minus 0.7. And after you get the VE, if you calculate the current IE here, easy. IE equal VE divide RE here. And if you want to calculate the IB equal IE divide beta plus 1. The R1 and R2 form a voltage divider.
Hey, Mr. Pham,
Yes,
do the manufacturer or the people at the store, do they tell you what the beta is for the transistors?
exactly.
Oh, they do, right?
Yeah.
Okay.
You not decide. They given depend on what type of the transistor. Okay, this is a configuration we must know. Why? The thing is they using only one power supply. Okay, and they only need R1, R2 can make the transistor working very cheap. Okay, if you're using two power supply, then you get a problem. Cost too much. So guarantee if you see this circuitry, you're able to calculate everything we want here. Okay? Any question? Let's see. This is the circuitry here. They're telling you everything. You get the time, you can read it. Okay? Okay, now quickly, you do calculation and you tell me what VBB equal. Go ahead and working on that.
VBB is 3.5897.
Okay, you get
3.5897. 897.
Okay. Is it you get That answer.
That's it.
Anyone tell me? Did you get that?
Yeah, what you do is you take add 10K and 5.6K, that's 15.6, and then divide that into 5.6K. Hopefully that's
So
what I did, unless I hit something wrong.
Yeah, I got it. I got the same answer.
10 times R2.
Right. R1 plus R2.
Okay, VE. What VE?
VBB minus,
0.7.
yep.
IE.
VE is 2.8897. 2.8897. Lisa, did you get the same?
Yep, 2889.
Okay.
Okay, IE.
IE is VE is that, let me see,
Let's see.
divide 560.
BE divided by IE.
So it's 5.16 milliamps.
Oh, it's BE divided by RE?
Yeah, by 560.
Oh, okay.
And that should equal 5.16 milliamps.
Correct?
Yeah, that's close enough. That's good enough for government work, Mr. Pham.
IB.
IB is that's beta times IC, right?
Yes.
Okay, so that's 100 times the answer we just got.
Yep.
Now, we need the IC, right? Sorry, we have to calculate that way.
Beta times IB.
Okay, you have to calculate IC. IE, IB. Okay, what IB equal?
8.0. Okay.
IE divide 5.6.
Did I be twice? Okay. Hang on, let's see. We need PRC.
IC should equal 5.1089.
Yeah, that's close to IE.
Right, exactly. 5.1089 is the IC.
Now, how far do you go on that? I mean, is it okay to round it up or?
That's okay.
Okay.
The thing is, you never get exactly value.
Right.
They have to get targeted.
The main thing to know is that IE is just a teeny bit bigger than IC.
Little.
Yeah, little bit.
Say that again?
IE is a little bit bigger than IC. IE is the biggest, then next is IC, and the smallest is IB.
Oh, okay. Good to know.
That's the own of the formula.
So all we got to do is when you give us a problem like this, just put in the values and punch out the numbers.
Okay, so make sure you have to redo it. Please, you have to working on this circuit. Normally, if you get a job interview, they just ask you how to get VBB. Then you have to tell them, okay, VBB equal VCC times R2 divide R1 plus R2. If they asking how do we get VE, then VE equal VBB minus V 0.7. If you want to calculate the IE, then you get the VE divide RE. You don't have to do calculation, but you have to tell them how do we get it. This is very, very important. Everyone have to do it. So, any question? Okay, now, this time, same thing. Only different is they using P and P. So this is the base. Okay, collector, admitter. So VBB, same thing. VEE, tab R1 divide R1 plus R2. Same thing. Now, who can tell me what VE? Just talking about the formula. How do I calculate the VE?
So the,
right here.
yeah, so the, instead of plus 0.7, you got minus 0.7, right?
VE mean from here to round.
Right.
VBB mean from here to round. Okay?
Mm-hmm.
And the difference will be 0.7.
7.
So
I think what he's saying is because it's a PNP, it wouldn't the value of the diode be a negative 0.7?
okay, now this 0.7 here. Correct?
Right.
Right.
So from here to here, how many volts?
From where to where?
From admitter to the base here. Admitter to the base. How many volts?
Zero point,
0.7.
yeah.
0.7.
7.
From here to here, you already know. So now you want from here to the round. Then VE equal 0. Plus VB. Is it correct?
Oh, it equals 0.7 plus the base voltage.
Exactly.
Okay.
The thing is you already know here, 0.7. From here to here, round. Okay. And now VE, we already know.
Mhm.
IE,
IE is VE divided by
BE divided by RE.
RE.
IE, that right here, right?
Right.
That right here. This is VE, this is VEE. So basically, VEE minus divide RE.
Okay.
Okay? IB equal IE divide. Remember, the formula apply to both NPN or PNP.
Right.
IC beta IB. VC. If you're looking into the circuit, can you tell me how do I get VC right here?
Let's see. Okay.
You
Oh,
get the current
VC
here.
It would be
is VC is the same as VC. You it's the drop over the RC resistor.
yeah.
Here, the formula.
Oh, okay, so it's it's RC times IC. IC times
Are,
RC.
are we trying, okay,
Because Ohm's law is voltage.
Yeah.
Voltage is current time resistance.
Mhm.
You agree, Mr. Pham?
Yeah.
Okay.
AC.
Oh, VEC. That's the opposite of VCE for the other one. So it's VE minus VC. Okay.
hmm,
Okay, Mr. Pham. So
Yeah.
now you got you gave us the circuit with the NPN. You gave us the PNP with the arrow pointing in, and there's one other, right?
Yeah.
Okay. Oh, this is the other one, correct?
No, that's just a PNP.
I know, but the other one was with the arrow up top, and this one with the arrow down the
a
bottom.
little different.
oh, yeah, look at that.
However, they given you everything here.
Mhm.
You guys have to pay. See that? They given on the formula. Okay?
Okay,
Hey,
So
Mr.
you
Pham,
have to do.
Mr. Pham, before you go real quick, can you just go back to the other screen, not this one? Yeah, right here, right here, right here.
Yeah.
So the
Well,
arrow is up top pointing down. Now go back to the next one. Oh, okay. Yeah,
they are different.
yeah.
However, in here, you know, that will be admitter. That will be collector. And that will be base.
Mhm.
That's only the difference. But on the formula, they already give. Okay? You have to spend time.
Okay.
That little connection. Okay, now you get a Q1. They get a beta 1. Q2. You get a beta 2. If they connect this way, the final beta equal beta 1 times beta 2. I given you example. This 100, this equal 100. So you can see beta will be very, very big number. Very high current. That's what they call a dark Linton connection. So if you're working on this kind of circuitry, have to be very, very careful. The thing is they very high current. If you get a short, they can burn right away. Okay? If they want more current, that means they connect dark Linton. And this is, they can build inside one IC. Okay? This one you're using 2 transistors to build. They're working the same. Okay? Again, this is a very, very high current. When you're working with the Duck Linton, must be very careful.
Hey, Mr.
Otherwise, you
Hey,
can
Mr.
cook it. Yeah.
So like when you're working with these things, there's they high current, that means it heats up the wire or whatever. Do you need like resistors that like 2-watt resistors? Do you know what I'm talking about? Where you
Yeah. When you get a high current, so the resistance have to be big. Otherwise, they burn it out.
yeah, that's what I mean. You have like those those big, you have like the 1/8 resistors or 1/2 or whatever,
Yeah,
2 watts or whatever they call
right,
it. So you want the big one.
right. However, I just make sure the thing you not design, you'll be working on. When you see this schematic, have to be pay attention.
Mhm.
Okay?
Okay.
Otherwise, if they short it to the round, they cook right away.
And if you have a certain smell inside the classroom, you know somebody burnt a transistor, right? I mean, it's happened before.
So
A fire on,
basically, this cover on of the DC bias for the transistor. Okay? Next week meeting, we're talking about amplifier. That
Okay.
means we learn about common emitter amplifier, common collector amplifier, and common base amplifier. Okay?
Yeah.
Hopefully, next week we can done with the transistor. Okay? Then
Okay.
you can go to the operational amplifier. Anyone done for your assignment, done the quiz, and a lab vote, automatically after this semester, you will be go to Tech 2. And also, you will be get the Tech 1 certificate. No problem. Okay, any question?
hey, Mr. Pham, was there any problem with any of the homeworks needing to update?
What do you mean, update?
Was there a problem with any of the homeworks needing to update from the answers?
No,
Okay.
I will looking into to see you done or you not done. Assignment, homework, if you done, they pass to upload to get credit. And the quiz will be let you know what score you get, what grade, A or B, or C or D, or E.
If they need to check, I guess what I was trying to say, if you need to check a homework to see if it's correct, what should we do?
No, if it's not correct, then they not pass.
I know. So
Then you have to ask instructor.
okay.
Any instructor in the lab, they know the key.
Okay, got you.
If you ask me, I don't need the key.
Okay, but we got you.
Okay, sorry, I still get a little problem. Okay, I will try to correct everything. However, now the boy okay, right? No,
Yeah.
okay.
So
I know.
Mr. Pham, what you want a new iPad and a new computer for Christmas, right?
No, it's all my new.
Oh,
Only thing we hit into a problem, but I think I know how to fix it.
You should take it back, Mr. Pham, and tell them you need a new one. Tell
So
them it was defective when you got it, so you want to switch it out.
normally I've been in the class on Monday. Okay.
okay.
Next week I'm not teaching textual. However, textual I will be teach them on the Zoom, but on Wednesday. However, I still go to the class. Whoever get a problem, left phone problem, homework problem, or quiz, I can help you out.
What day was that?
Monday.
Monday.
Normally, I go up to the class to see how your guy doing. If you know how to do left phone, that means you easy to be a technician. Okay?
All
Awesome.
right. Thanks, Mr. Pham. Good night.
Thank you, Mr. Pham.
Okay. Let's see. So, if you want to see, okay, let's see, leave it. So, good night,
Good
everyone.
night.
Good night.
Good night. Thank you, Mr. Pham.
Thank
Okay.
you, Mr. Pham.
Bye bye.
Thank you, Mr. Pham.
No problem. Okay.